Welcome to this Microsoft Azure Training Day. Our focus for today is on migrating on-premises server infrastructure. Today's discussion is spread over 3 sessions, each roughly 45 minutes. In this first session, we're going to focus on how to modernize your existing server infrastructure to Windows Server 2019. Modernizing your infrastructure has many advantages, not just because of the end of support of Windows Server 2008 R2 and SQL Server 2008, but because of the new features it enables, including many hybrid cloud features. This session will be followed by a session on how to configure hybrid cloud infrastructure, followed by a session on how to migrate workloads to Azure. Over the next 45 minutes or so, we will share the story of Tailwind traders and their IT department faced with modernizing their environment in order to support their cloud-first strategy, but also still working with their on-premises technologies that need to keep running in order to keep their engine alive and working. Tailwind Traders is a company who has grown organically over the years to a point where their on-premises infrastructure has not kept pace. New technologies have come in and they've been implemented, and they're working and they're solving specific problems. And they're now using Azure and a mix of hybrid cloud and cloud native approaches. However, their on-premises infrastructure really hasn't kept pace at all, and the IT department is currently in a situation where they're at a turning point and they have to make a call on what they can do for the future. Tailwind Traders is looking at trying to modernize and move stuff into the cloud environment because scale is available up there. Flexibility and reliability, all the goodness that cloud technologies can bring. They realized that on-premises technology still plays a key role and it has to be maintained and updated in order to leverage some of these new things. They're forming a plan to go ahead and migrate to a more modern, better managed and more secure infrastructure on-premises in order to keep up with this growth that is coming. Tailwind Traders is like most organizations. They have existing on-premises infrastructure and a number of branch offices connected at various sizes. At each location they have an Active Directory domain controller to handle every single authentication to any resource on their network, file shares and so on. It is the single source of truth for everyone's identity. They also have, based on the size of the office, additional application servers, point of sale systems, reporting services that might be candidates all for moving to Azure. All servers are running on aging hardware and are covered by expiring or expired support agreements from hardware vendors. Their spare parts inventory sometimes has to come from purchases on eBay. Core infrastructure services like file shares or DHCP services are also provided using aging hardware. Now take this basic architecture and multiply this by a number of sites, each having a similar makeup for the required services being provided to its users. You can start to appreciate the scope of the project and the challenges the IT department will face. And now expand that to 30 different locations around the world. It should start to be clear that a strategy of simply moving everything to the cloud does not make sense. You have to be prescriptive on which workloads are suited for the cloud and which ones are not. Active Directory is essential by many on-premises systems and applications. It can't simply be moved to Azure, it needs to be maintained and modernized. Core infrastructure like DHCP servers, internal DNS, they're also critical for making the on-premises network work, and they should be modernized. Application services and specific custom workloads, well, these are good candidates to move to Azure, and we'll look at migration in a later session. File servers, well, on-premises access is vital, and modernizing offers a way to take advantages of scale and backup and synchronization across sites by using the cloud. Microsoft's own telemetry shows that many 2008 servers are running domain controllers or file servers, and we're going to look at how these can be updated. The last time Tailwind Traders took a long hard look at their internal architecture was 2008. With the migration from 32-bit Windows Server 2003 to a 64-bit 2008 R2. This was the early days of production virtualization with VMware and the introduction of Hyper-V. No longer did they provision on bare metal, there was much more agility to deploy more servers and systems faster. More application servers and systems were created in an explosion of data which had to be analyzed and opened the door to new insights and analytics. This growth explosion of resources led to more effective use of hardware investments and server sprawl. As a result, Tailwind Traders has a very large install base of Windows Server 2008 R2 and SQL Server 2008. The end of support date for both of these has now passed. These systems are no longer receiving routine security updates, and you cannot call Microsoft for assistance. This creates a security and availability risk for Tailwind, as well as a regulatory compliance concern. You can pay extra for support on premises, or by moving the service to Azure, you get 3 years of free extended security updates. If you do this, please be sure to make a plan to migrate off 2008 in good time. Don't create an emergency 3 years from now. Here's a nice workflow that shows your options for Windows Server and SQL Server 2008 end of support. You've got 2 paths: move to Azure or modernize on premises. On the Azure path, you can migrate your database to a platform service such as SQL Database Managed Instances. Or you can stick with Azure VMs, perhaps upgrading to a newer OS or database version, or sticking with 2008 and taking advantage of extended security updates. Alternatively, you can keep the workload on premises, either upgrading to a supported version or paying for the on-premises extended security updates. Tailwind Traders is seeing a confluence of triggers coming together. The IT triggers like data center contract expiry, integrating acquired assets, and the end of support for hardware, operating systems and software. And they also see business triggers such as application innovation using DevOps processes, AI and big data. To move forward, Tailwind will start with assessment and then planning and then execute on that plan. For first-party applications, they're going to look at replacing the cloud-based services such as Office 365, Exchange Online and SharePoint Online. For line of business apps, they'll look at migrating into Azure, perhaps taking advantage of the extended security updates and support for Windows Server 2008 R2 and SQL Server 2008. And for critical Windows Server infrastructure such as domain controllers, DHCP and file shares, they're going to look at modernizing on premises. And that's what we're going to look at next. So, what challenges do they face? They need to understand what infrastructure they have, and they have limited resources to investigate and assess. They have domain controllers running on Windows Server 2008 R2, and they have DHCP servers handling IP assignment in each office. And they have a range of critical file servers which need to be modernized. Let's get started with some tips on how to investigate your current infrastructure. Let's look at some ways you can easily investigate your existing infrastructure using LDAP queries against your domain controller. So here I am in Windows Server 2019, and I'm going to start in Active Directory Admin Center. This has an easy graphical interface and is good for LDAP queries. So just browsing the forest structure, you can see that we have some OUs, we have some users. It's a live directory. But if we look inside the computers view, you can see the default view doesn't show me the OS version, it just shows me the computer names, so that isn't so useful. So let's go to the global search and we'll use an LDAP query. And we'll just take a moment to configure which columns we're interested in seeing in our output. We have the operating system and the operating system version. And then it's a very simple query that I'm going to use. We're going to query for a computer object and query for a string in the operating system name. So computer object category equals computer, and the operating system is Windows Server star. So run the query, and we can see all of our servers. We can sort by operating system, and you can see which OS they're running. So we can refine this query to show only our 2008 servers. We'll just add that into the query string here. And we can also run the same query using PowerShell. If some people are PowerShell fans, we just do get AD computer, and we use a filter for operating system, Windows Server 2008, with the wildcards, And we'll access all the properties and then send the result into a table where we'll select which columns we want to see. And there we have it. So now I have a list which I can use as a starting point to make my upgrade plan. There are also some other tools you can use. The Assessment and Planning Toolkit, or MAP Toolkit, is a free tool to assess if a particular server or application is ready to migrate to a new OS or to Azure. It provides detailed reports on upgrade and migration readiness. Azure Migrate and third-party tools can be used to assess on-premises infrastructure for readiness to migrate to Azure. And there's also the AD Explorer tool from sysinternals, and there are detailed docs available online on how to search AD effectively. So, we've addressed the first of our 4 challenges. Our next challenge is how to migrate our domain controllers off of 2008 R2. Let's look at a demo of how to modernize AD by migrating from Windows Server 2008 R2 to Windows Server 2019. To save time, some parts of the demo have been time warped. To start with, I have a 2019 server, which is simply a member server within my Active Directory. As a first step, we'll go ahead and install the domain services. This will install the AD service on the server together with the admin tools. Okay, next we're going to install a domain controller. So install AD DS domain controller. We don't need to create a delegated DNS zone. The domain name is needed, tailwindtraders.net. The site name is just a demo text. We'll specify paths for the database, the logs and the sysvol, and we'll suppress the reboot on completion. Okay, we need to specify the safe mode admin password, so be sure to choose a secure password and to document it safely. And we'll let that run. Once that's complete, we'll restart and log back in again. Let's open PowerShell and see if everything is running as expected. And yep, we can see that our services are running. And if we check our domain controllers, you can see our new server on the .10 IP address and the original 2008 server on the .100 IP address. So our new domain controller is working and replicating happily, and you should wait a while at this stage to make sure that the replication completes. So next we need to transfer the FSMO roles to the new server, and there are 5 roles that each have to be identified on a specific domain controller. And for this demo, we'll move all 5 to the new domain controller. Okay, all 5 are now moved to the DC02 domain controller, and let's switch to our legacy domain controller, which is DC01. We're going to run DC promo. Our server is already a domain controller. We're going to use DC promo to uninstall AD on this server. So here's the wizard. You can see it says use this wizard to uninstall Active Directory services on this server. It warns me that it's a global catalog server and we should make sure it's not the only one. That's okay. and it's do I want to delete the domain? No, I don't. And this server is also a DNS server, and with the AD integrated DNS zones, they will be deleted. And here we can delete the DNS delegations that point to this server if there are any in the parent DNS zone. So that requires credentials. We need to provide the password for the new local admin account, and we let it run. It's going to ask to reboot. I'm going to say no, because I'm going to shut it down forever. This server has been working for us for 11 years, and let's say goodbye nicely. So shut down. And thank you for your service. Oh, and unfortunately it wasn't fully updated. All the more reason to upgrade to the new one. Okay, back on our 2019 server. Now I can change the IP address to .100 to take over the IP that was used by the old domain controller. And from here I'm just going to restart the server to make sure everything is running cleanly and picked up that change. To recap, here's the process. Leave your existing Windows Server domain controller as it is. Set up your new Windows Server domain controller and synchronize with the new Windows domain controller with the old one. Promote the new domain controller, transfer the FSMO roles, demote the old domain controller, and repeat this at each site where domain controllers exist. With your modernized AD infrastructure, you can raise the functional levels in AD to take advantage of new features in AD. For more details, see the link on the slide. I expect your new domain controller is running as a VM in Hyper-V, right? Did you remember to use a shielded VM? A normal VM in Hyper-V is just a collection of files. Your admin can steal your domain controller simply by copying those files to a USB stick and walking out of the door. With a shielded VM, the VM is locked to this specific host. Only a shielded VM can protect you against a rogue admin. This is your organization's safe, it's your vault, so please treat it as such. So we've migrated our domain controllers, so on to the next challenge. How will we modernize the DHCP infrastructure that manages IP assignment in each Office network? Let's have a look at a demo of how to complete a DHCP migration from 2008 R2 to Windows Server 2019. Here is my 2008 R2 server running DHCP. It has an IPv4 scope, and there are live IP leases and also some IP reservations. And I need to migrate this to Windows Server 2019. So here is a 2019 server. This comes with server migration tools, and they've been around since Windows Server 2012, but they still work. So let's install those tools. And we'll move to the folder containing the tools. And the next step is to build a package specifying the source OS, in this case 64-bit Windows Server 2008 R2, and we'll put this package in a shared folder. To make this, it's a simple one-line task. Okay, on the 2008 R2 server, we'll browse to that shared folder where we made our package. And we'll copy this locally. And now on our legacy box, we simply execute the tool. There were no parameters required. It's just smigdeploy.exe. And this opens a PowerShell window with the correct modules installed. So we'll stop the DHCP service, and that shouldn't break existing clients. They still have their DHCP leases. And then we're going to run export SMIG server settings, specifying the DHCP and including the users and IP config settings of the NIC, and we'll save that onto our file share. I'm also going to need the MAC address of this server, which I'm going to get by running ipconfig and saving the output to our file share. So ipconfig and save to the file share. And we have what we need now, so we can shut down our legacy DHCP server. It's been a great friend, but its time has come. Thank you for your service. Okay, so back to our 2019 server. We'll install DHCP, including the management tools. Now there's a warning that we don't have a static IP configured, and that's true. We can see it if we look at our IP settings. These are configured for DHCP. And the migration tool will fix all of that. So let's open the migration tool. And now we'll run to import the SMIG server settings for DHCP. And I need to give the MAC address of the old server, which we saved to our file share. So let's just get that. And I also need to give the current MAC address of the new server, which I can get from an IP config. So finally I point to the file share, and this gives an error when we run this. But if you check the IP settings, you can see that everything did actually work. They have been imported. We'll run the tool for a second time. This time we're only going to import the DHCP data and not the IP settings. And this time no error message. And we can now verify that the DHCP service has been configured with all the reservations in place. So we can see we have our server there, we have our scope, we have the address pool, we have the leases, they've been carried over, and we also have our reservations. And now if I switch to a client machine, we can run an ipconfig renew just to confirm that DHCP is still working on our network. And there we have it. As a reference, there's detailed documentation available for both how to migrate DHCP and how to manage IP configurations. We've now addressed 3 of our 4 challenges. There's just one left to go. How to update our legacy file servers. To migrate our file savers, we can use the storage migration service, which is part of Windows Admin Center. Let's have a look at a demo. Here is our file share on 2008 R2. You can see that we have a share called data, a local user account, and a local HR group. These will all need to be migrated. And there's also another share called sales, and this also has a local sales group, which you can see here. There are also several local user groups here: local finance, local HR, local marketing, local sales. These local groups all need to be migrated. They're in active use. And there is also a break glass account. So what this means is I can't just robocopy the files over. If you do that, you're going to miss all these other configuration details, and you're going to break existing applications or existing users. So we need to be smart about how we do the migration and make sure everything is copied over appropriately. And here we can just see that we do have some real data on the server. Okay, so here's my new Windows Server 2019, and I'm going to use Windows Admin Center here. So here I can see a list of servers. It's all through this web-based Windows Admin interface. If you're not using Windows Admin, then it's a great service, so you should absolutely check that out. Here I'm going to choose FSO2, that's my new file server, and I'm going to connect to the file server. And you can see that here's my server. If I go to the storage item, you can see that I have an unused disk here. You can see disk 1 is not being used. And we can use Windows Admin Center to remotely create a volume on this disk. So we'll choose the disk and we'll create a volume. We'll call it the E drive. We'll give it the name data, use the full space, and that will get formatted. So that's powerful. We can do all of that remotely from the Windows Admin Center across our estate. So now we'll just go back to our list of servers from the Server Manager. And I'm going to choose a different server, which I'm going to use as my proxy. This is where I've installed the storage migration service, and this is what the server I'm going to use to copy the data from my old file share onto the new file share. So we do that, we create a new job, and then I specify the source device. I give the job a name, choose the source device, and that's going to be my file server 01. That's my 2008 box. Now I can scan that device, and that will show me what I have on that box. You can see that the scanner succeeded, and it shows all my different file shares and so on that have been discovered. I can see I've got my different shares there. You can see there's a test share there. That one might not be worth transferring. So this discovers everything I have, and now I can specify the destination server, and that's our FSO2 server. So we'll choose that as our destination. That's our 2019 box, and we'll scan that device as well. And you can see that the service has detected the space I have available, and it's made a suggested mapping of how the file shares on the legacy server should be mapped across onto the new server. And I can review this mapping, check that I'm happy with what it is suggesting. In my case, I'm going to exclude that test share. We can take that out of the mapping. It's quite fine-grained what we can do here.
And I will let you know the quantity as well.
So next, I specify some basic settings for the transfer. And for example, how many retries I need. There may be some files that are locked and they will need to be retried. So we can choose those details, and now we can validate that everything is in place. We have all the necessary permissions and so on. Okay, that's passed. And at this point, we're ready to start the transfer. And this, of course, will generate significant network traffic. So you might want to choose that you do this outside of peak hours. The transfer is highly optimized. It's faster than using something like Robocopy. Heavily multi-threaded. And if we can monitor the transfer, we can see the progress that's being made, and you can see the result is still running at the moment, and you can dig into the details of all the different shares that are being transferred over. And you may get some error messages. You can see the little red exclamation mark there. There may be certain files that it was unable to transfer, for example. We can dig into those error messages at the end and investigate them. We'll show you how to do that. Okay, here we go. So let's go into the errors, and you can see here we can download the error log. Open that in Notepad, And you can see here these are various files that it wasn't able to transfer. Maybe they were in use at the time, and these can be investigated and remediated if necessary. You can see there's recycle bin files and so on here that perhaps we're not too concerned about. So these have been skipped. And we can also look at the migrated users log to see which users have been transferred over. And you can see here the local break glass account that has been transferred. So that's great. That's been done for us. And similarly, we can look at the migrated groups log, and we can see which groups have been transferred. Now, there's quite a few groups on a box like this, but we can see that those local finance, local marketing, and so on, those special groups we had, those have also been transferred over. Excellent. So next, we want to make sure that our clients move over to this new box, but rather than reconfiguring all of the clients, we have a cutover feature here within the storage migration service. So we can have our new server take over the IP of the old server. So we're going to tell the old server to move on to DHCP, and it can get itself a new IP address that way. Okay, and then we can choose on our new server, we can choose the network adapter that it's going to cut over to, and we can choose a new name for the old server. Obviously the new server is going to be renamed with the name of the old server. We'll rename the old server with the same name -old, and we'll have that transfer take place, and that will cut over. Okay, we can just validate. Great. Okay, so that will cut over the server from the legacy server to the new server, and our clients will not have to be updated. So it's a seamless change as far as any of our clients are concerned. To recap, Storage Migration Service provides a powerful tool for migrating your data both into Azure and into modern on-premises storage platforms based on Windows Server. It offers a highly optimized performance, reliability, and scalability, and is very easy to use. The Storage Migration Service supports the full range of Windows Server OS versions from 2003 onwards as the data source. It also supports failover clusters and Linux Samba servers, and has been tested against a wide range of popular Linux distributions. It's part of Windows Admin Center and is included in Windows Server 2019, both standard and data center editions. A data migration using Storage Migration Service takes place in 3 phases. First, you specify the data sources. The service reviews these sources to check for data volumes, as well as other important settings such as local users and groups. Next, you specify the destinations and how sources and destinations are mapped, choosing what data to transfer. The Storage Migration Service executes the data transfer. And finally, the Storage Migration Service can also handle cutover of storage access endpoints to the new storage system. This updates the IP addresses and NetBIOS names and other settings so that the new storage server can take over seamlessly from the old storage server without you having to reconfigure any dependencies. Storage Migration Service is fully documented. Use the link on the slide for more information. The service is under ongoing development. New features include migrating data to Azure Files and helping you set up Azure File Sync on the local destination server. So, how does our Tailwind Traders on-premises infrastructure look after these changes? We have updated our Active Directory infrastructure, which is now running on Windows Server 2019. Likewise, our DHCP servers and file servers have also been upgraded. What's more, all these upgrades were achieved efficiently, safely, and without disruption, requiring no downtime or reconfiguration of other systems. That just leaves our application servers, which we'll talk about more in the following sessions in this class. We've now completed the first of our 3 sessions for this Microsoft Azure Training Day. For our second session, we'll look at how you can integrate your on-premises infrastructure with cloud technologies in Azure to deliver a range of scenarios. To showcase these hybrid cloud features, we'll continue our journey with Tailwind Traders. Tailwind traders decided to implement Azure hybrid technologies to better manage and extend their on-premises environment with Azure Cloud Services. In this session, we're going to have a look at how they do this. Let's have a look at the agenda. We'll start by reviewing typical customer challenges and how a company like Tailwind Traders can address these by using Azure hybrid services and what the different hybrid cloud approaches are. We'll then look at how to implement certain popular hybrid scenarios, connecting to Azure hybrid services within Windows Admin Center and Windows Server. We'll finally also have a look at how you can use Azure to manage your on-premises infrastructure, providing a unified cloud-based management experience. Broadly speaking, there are two approaches to hybrid cloud. One is bringing down consistent cloud services into the customer location, and this can be done through products like Azure Stack. The other approach is to connect on-premises infrastructure to Azure hybrid services. This session will focus on the second approach, connecting your infrastructure with hybrid cloud services. Let's start with the challenges which Tailwind Traders still faces, even with their modernized on-premises infrastructure. Like all companies, they need to make sure their on-premise environment is backed up. They also need a disaster recovery plan. They also need to manage their software updates across both cloud and on-premises servers. And for their file servers, they're concerned that they should be replicated and that they don't experience any capacity issues. The tools Tailwind Traders will use to make this work are Windows Server, Windows Admin Center, and Azure Stack HCI. Windows Server is, well, as we know it. Windows Admin Center is a web-based server management UI which delivers great remote management capabilities for Windows Server and also enables Tailwind Traders to easily connect to Azure hybrid services. In some office locations, Tailwind Traders is going to deploy Azure Stack HCI. HCI stands for Highly Converged Infrastructure. It is an IT architecture in which the compute, storage, and network resources across multiple servers are all virtualized, pooled, and managed together. Azure Stack HCI is part of the Azure Stack family of devices alongside Azure Stack Hub and Azure Stack Edge. Azure Stack HCI is based on Windows Server and Windows Admin Center, using validated hardware from a wide range of hardware vendors. The first challenge Tailwind Traders faces is backup and disaster recovery for their on-premises servers. Let's look at how a hybrid strategy using Azure Site Recovery can help. For this talk, we'll focus on disaster recovery. For Tailwind Traders, implementing disaster recovery using traditional infrastructure is very expensive, complex, and lacks flexibility. They have trouble with their initial replication, and their DR facilities don't always meet the distance requirements for full isolation between facilities. Let's have a look at how Tailwind Traders can use Azure Site Recovery as a DR solution. We're going to use Windows Admin Center to configure Azure Site Recovery. We have Windows Admin Center connected to our on-premises Hyper-V VMs. If I click Virtual Machines, you can see I have 4 VMs, and I want to set up DR for this one, app02, by replicating it up to the cloud. So I'm going to select app02, scroll down here on the context menu, and then select Protect VM. And you can see from my Azure subscription and location they're filled in already. That's because I've used this service before. And I need to choose which storage account I'm going to use for the replication. I can choose that here. And Protect VM. Now I'll just cancel out of that because that can take a little while to run, so I'm going to switch to a different machine, the app01, which I have replicated already. You can see here the disaster recovery status shows as protected, which of course is how it should be. And if I click that link, it will take me over to the Azure portal, showing me the recovery services vault status for that machine. And you can see here again the replication health is healthy, the status is protected. That's all looking good. If we click into the VM, We can see a simple dashboard that shows us the replication health again, and also the RPO showing 5 seconds based on the last incremental update. We can see if there's been a failover test recently. You can see here, never performed successfully. And there's some additional settings we need to configure. For example, the resource group that the failover VM will be deployed into, that needs to be set before we could do a test failover. We can also configure things like an availability set and any additional network settings. We could set a static IP on the NIC, for example. Various other settings we can tweak from here. There's 3 different types of failover we have available. We have the planned failover, the normal failover, and the test failover. And the failover option is used when you have an unexpected outage in your data center. So it spins up your VMs in your failover environment and also sets up a reverse data sync so you can fail back again later. And the planned failover is similar. This is, however, when you need to temporarily move your workload due to perhaps some planned maintenance. There's some work you're doing in your data center and you need to move the workload temporarily into Azure while that work is taking place. And then the test failover, this is a little different. This performs a failover into a separate test network while leaving your on-premises environment running. And that's very useful for checking that your replicated machines are able to spin up in Azure with the recovery data that you've been replicating. Azure Site Recovery can take a coordination and data management role, orchestrating failover between on-premises environments. It can also use Azure VMs as the disaster recovery site, providing physical distancing and avoiding the substantial upfront costs associated with operating a DR data center. This works with System Center Virtual Machine Manager, VMware vCenter, or just Hyper-V or ESXi with vSphere. This allows enterprises, branch offices, or even small and medium-sized businesses to use Azure and ASR as their full DR solution. The next pain point for Tailwind traders is managing updates across multiple environments and different operating systems. As we all know, ensuring our operating systems are up to date is a big part of reducing the attack surface for our environments. And let's see the challenges that Tailwind Traders faces. Tailwind Traders needs to ensure that physical and virtual machines, both on-premises and in the cloud, and running Windows or Linux operating systems, they all remain current with software updates. They need a centralized update management tool that can handle update management across their entire estate. And this includes assessing the update status and centralized management and rollout of all updates. Azure Update Management will do all of this for you. It allows Tailwind traders to check update compliance of their Windows and Linux computers, both on premises and in Azure IaaS. It allows Tailwind traders to deploy and install software updates to Windows and Linux computers, both on premises and again in Azure IaaS. And it allows Tailwind traders to avoid having to use different products depending on the operating system or where their computer is located within the hybrid environment. Note also that you can have Azure Update Management work with your on-premises Windows Software Update Services servers to deploy updates closer to your targets. Let's have a look at how Tailwind traders can manage their on-premises servers using Azure Update Management. Here we are in the Azure portal, in the Update Management solution in our automation account. You can see I've already added an Azure VM and it shows as compliant. I can also add more VMs or non-Azure VMs from here, and that's what we're going to do, but rather than add the machine from the Azure portal, I'm going to show you how to do it from Windows Admin Center. And here in Windows Admin Center, we'll select the Updates extension where I can manage the Windows update settings for my server. Now I could just update the server from here, but instead I can integrate it from here into the Azure Update Management solution. So you can see here if I click Update Now and then log in, I can select my subscription where the Update Management solution is deployed. Then I choose my resource group, and the region is selected for me. I choose my Log Analytics workspace, and the automation account. And in each case, if they don't already exist, then Windows Admin Center can also create those for me. So then I will just click Setup, and this will integrate the VM into the update management solution. We'll just wait a few moments for that to complete. Okay, that has been successful. Now if we go back to the Azure portal, okay, you can see my new machine there, the WAC machine. This has been registered and is showing as non-compliant. So let's fix that. We'll schedule an update deployment. We give the deployment a name. It's a Windows deployment, and we can now choose which machines to update. Now we can do that through a group, and it could even be a dynamic group, for example, based on tags, but in our case we're just going to specify this individual machine. So specify it's the WAC machine that we want to update. Okay, that's it, that's the one. And now we can configure which updates we want to include. We have the different classes of updates there, and we can also include or exclude specific updates if we want to. We'll say when the update will happen. We're going to do a one-off update here, but you can also set a recurring update if you prefer. And you can also configure scripts that run before and after the update, although we won't need to do that here. We can say what the maintenance window is and choose our reboot option. In this case, reboot if required. That seems to make most sense. So we'll create that schedule. Okay, now that will take a little while to run. If we check our deployment schedules, you can see that it is scheduled to run. There on the on-premise, and if we move to our history when it's finished, okay, there it is. The update has been completed. You can see it took 10 minutes. I've sped it up on the video. If we click into the details, you can see a little report showing there was one machine that was updated in this case, and the updates have been 3 updates have been successfully deployed. So now we've just used this to update a single machine, but you can imagine that this is very powerful. You can see my 2 machines are now compliant, and this is very powerful. You can imagine scaling this across hundreds of machines across your entire environment. This will enable you to group them and patch them and manage what type of patches are deployed at what time. A very powerful solution for managing all of your updates in a single pane of glass. Let's recap and review how Azure Update Management works. It leverages the following components: the Microsoft Monitoring Agent, or MMA, for Windows or Linux. This is also known as the Log Analytics Agent, or OMS agent. It uses PowerShell DSC for Linux, and automation using Azure Automation and hybrid runbook workers. Azure Update Management supports on-premises servers, both physical and virtual, as well as VMs across multiple subscriptions in the same Azure AD tenant. Compliance scans are completed every 12 hours for Windows and every 1 hour by default for Linux. In addition, on both Windows and Linux, an on-demand scan is triggered within 15 minutes of the Microsoft Monitoring Agent being deployed or restarted. For update deployment, Linux computers can check against a local repo or a public repo. It takes 2 to 3 hours for an update to be available after CVE release. Windows computers can check against MS Update or your local Windows Server Update Services deployment, and it takes 12 to 15 hours after release for an update to be available for assessment. Update management supports a wide range of Windows Server and Linux operating systems. And please note that Windows client operating systems, such as Windows 7 or Windows 10, are not supported. Update management also supports Azure Stack VMs, which are handled like Azure VMs. We've discussed disaster recovery and update management. The third challenge that Tailwind traders faces is managing their file servers, making sure that data is replicated, managing storage capacity, and providing a DR and backup solution. To address these requirements, Tailwind traders will deploy hybrid file shares using Azure Files and Azure File Sync. The starting point is their file server in New York. Azure File Sync will be deployed to synchronize this server with Azure Files. The cloud becomes the main data store, with the local server simply offering a local access point and a cache of the most recently used files. This preserves fast local access for most files, and at the same time enables the file share to scale beyond the storage capacity of the local file server, so Tailwind traders don't have to worry about storage capacity anymore. The Azure File Service also makes the file share available to applications running in Azure VMs. Changes made either locally or in Azure are automatically replicated. Additional file sync deployments provide local access to files in other branch offices, for example in Seattle. Rather than each branch running separate file servers, a single file share can be shared across the company. Changes at any location are synchronized globally, while maintaining the performance associated with local access. Azure Backup is used to back up the file share, enabling data to be recovered in case of accidental deletion or corruption. And if a local file share fails, it is straightforward to deploy Azure File Sync to a new server pointed at the file service and have a replacement server up and running in no time. For our next demo, let's see how Azure Files and Azure File Sync are deployed in practice. Here we are on file server 1. This machine is running in New York, and we have a file share with lots of Tailwind traders documents, including a folder with our super important files. And this file share has already been synchronized using Azure File Sync up to Azure, and if I move to the Azure portal, you can see I have the File Sync service, and the sync group is called the Tailwind Traders File Server, very imaginative. And if I look at the details, you can see I have two endpoints. One is the cloud endpoint for the Azure file share, and the other is the server endpoint for the on-premises server in New York. And you can see it's using a local file share on that server. If we switch now to look at the file share in our storage account, I have this in another tab, and you can see if I open that file share, you can see all the different files have been synchronized, including our super important files. Okay, and this is being synchronized, both ways between the file shares. And if I switch to our file server 1, you can see that synchronization working. I'm just going to create a new folder here within our file share, and I'm going to call it folder 1. And if we switch back to our Azure Files share and refresh this view, you'll see folder 1 has appeared, synchronized from using Azure File Sync. So that works. Now what I want to do is to onboard our Seattle server to sync against our file share. So I'm setting up a new file share in Seattle. So this is the blue machine that I have here. This is file server 02, and you can see at the moment the file share folder here is empty. So I will need to add this as an endpoint in Azure, but the first step is to deploy the sync agent on this file server. And to do that, we'll use Windows Admin Center. Okay, so I just need to navigate through Windows Admin Center. We'll just choose the right location here. Okay, Windows Admin Center, and our file server 02. We'll connect to that server, and we can choose the Azure File Sync extension here on the left, which will help me to set this up. First thing is to install this file sync agent. Now I'm going to do that here using Windows Admin Center, which is the easiest way. If you're using Admin Center, just click Setup and then Next. You can also download the agent directly from the portal and install it that way, but this way is faster. So let's just select our options there, and we'll wait for that to install. Okay, the next step once this install completes is that we need to register this server against our Azure File Sync service. So I'm going to log in into my Azure subscription, provide my subscription credentials.
We also applied for so many tickets, okay?
And I'm going to choose my resource group, choose my subscription, choose my resource group, and the sync service is selected for me. Click next, and now I'm going to register this server with that sync service. And finish. Okay, we're not in the sync group yet. All we've done is register the server. So now I'm going to go back to the Azure portal. I go to my sync group and I want to add file server 2. So I'm going to specify the path on file server 2. Choose the server here and specify the path on file server 2 that we're going to use. And here I can enable cloud tiering. This makes the server act as a cache only of the most recently used files on the file share. And I can specify how much disk space to keep free. I'm going to say 20%. And I'm going to keep cached files that have been used within the last 60 days. And this enables me, to, of course, to take advantage of cloud scale, regardless of the size of the disk on my local server. I just get that local performance for the files that are actually in use. Now, okay, that's being provisioned. Takes a few minutes to synchronize. Now, of course, if I go to FileShare 02, all my files appear there, but of course, it's really just a cache of the most recent ones, although it appears as if everything is present from the point of view of any clients using this machine. So here I can see the synchronization works. If I create a folder here, folder 2, I can now see from FileShare 02, if I switch back to our cloud endpoint, you can see again if I refresh, our file share here now also shows folder 2 within it. And also if I switch to the file share in New York, our original file share, and refresh this folder, again folder 2 appears. So the synchronization is across all of our on-premises sites as also with the cloud. Tailwind Traders is using Windows Admin Center to manage both their updated on-premises infrastructure and their hybrid environments. Windows Admin Center is designed for small deployments, large deployments, and also for cloud and hybrid deployments. In this session, we've discussed assessing the Tailwind Traders approach for moving to hybrid IT. Using Azure Hybrid Services has made their on-premises IT better with features and services like Azure Site Recovery, Update Management, and Azure Files and Azure File Sync. That brings us to the end of this session on how to integrate on-premises and cloud technologies to create a hybrid IT infrastructure. We've looked at upgrading on-premises architectures and leveraging cloud services in a hybrid IT environment in our previous 2 sessions. In this last session, we'll look at how to migrate existing server application workloads into Azure. And to tell this story, I'm going to take the role of one of the IT engineers in Tailwind Traders. I'm going to tell you about the learnings and experiences we gained when we migrated some of our workloads from the on-premises environment into Azure. A little bit of background on Tailwind Traders. We are a retail company. We sell online home appliances, home decor, gardening tools, accessories, all kinds of different things for the home. We've been on premises for a long time and it's worked well for us so far. However, our leadership team met a few months ago and they reviewed all of our metrics, balance sheets, and made plans for our company to start going in a new direction. That new direction was passed down to the regional teams, and those marching orders were communicated to us in a rather interesting way. A short little memo sent by our management informing us that our New York data center is at the end of its lease, and there are no plans to renew it. So we need to figure out how to take all of the workloads and data and everything that's running in that location and move it to other data centers or into the public cloud. So that came as a surprise, and we saw it as an opportunity to update our skill sets and embrace the hybrid cloud model. Data center closures are only one of the drivers behind cloud migration. Other situations like quickly integrating an acquisition, urgent capacity needs, software and hardware refresh, security threats, compliance, application innovation using cloud-based technologies such as machine learning and big data, and software end of support are all other drivers that could have led our company to make this same change. So here's how we initially felt when we saw the news. So let's summarize our challenges. Our data center lease is ending, and we've already covered that. And this is compounded by the fact that after a quick review, our other data centers are also approaching capacity. And we're not going to move our workloads to a data center that's going to run out of capacity pretty soon. That would make no sense. So we decided to use the hybrid model to extend out our infrastructure to the cloud. And that way we can maintain control and we don't have to worry about further capacity issues. And we can start the modernization process to really start using native cloud services and extract the most value from the cloud. So moving to the cloud is not just as simple as grabbing all of your VMs and shoving them into the ether without thinking and planning behind it. We have to plan. And a solid plan is the foundation for a successful migration. Any issues missed during planning can cause our migration projects to run into trouble. This next section will cover a few of the prerequisites that we had to understand before we started our migration, and we used what we learned to make our migration plan. There are 4 basic topics we needed to review before we solidified our migration plan. Gartner, in a survey, identified that approximately 28% of all physical servers in data centers are what we consider to be zombie servers. A zombie server is a server that's taking space, using power, and taking time for your team for updates, but it's not actually running a workload, or it's running a workload that's just sitting there and not being used. No traffic, and no transactions, and no value. So our first topic is workload inventory. We need to collect an inventory of all the workloads that are running in the data center that we're vacating. We need to figure out who the stakeholders are and which department owns that workload. Is it still needed? And we need to figure out which servers are actually running workloads that are being used. This can be difficult, and as a last resort, we even had to resort to removing the server from the network and seeing who screams. I suggest that you don't shut it down, it might not come back up again. And once we figured out which servers weren't being used, we backed them up and retired them. And then for the servers in active use, we needed to decide which should be migrated and which should remain on premises. The second topic was to look at our network inventory. We did a thorough audit of our environments to review and document all of our networking requirements. Our address space, and how many subnets do we need? How many real public IP addresses do we need? And what kind of traffic are we getting? And then we had to decide how we'd connect our environment to Azure. We had to choose between a site-to-site VPN or ExpressRoute. Given the tight schedule constraints, we went with a site-to-site VPN. The third topic we looked at was our storage. We mapped all the storage to the workloads. For example, a website has a collection or a repository of images that we've been using, like pictures of hammers or dishwashers or tables and tablecloths and all that artwork. We had to map all of that stored data with the proper workload so that when we moved the workload, we'd also move the data that was needed with it. We also had to figure out what our actual space needs are or were going to be. Did we have lots of duplicates? And did we have data that was no longer needed? We found that when we did our review, we had areas on our file servers with backup data of projects that were cancelled 3 years ago. And we had backups of Windows ME machines that hadn't been on the network recently. And then backups of the gospel album A Flock of Seagulls recorded but never released. We defined our security plans for the data target environment. Is there PII information and is there a credit card number? And finally, we planned how to move that data, how it will be encrypted and how it will be moved from the on-premises to the cloud. The last topic was our identity context review. Are we going to extend Active Directory, or are we going to create a new infrastructure for our Active Directory? We have data centers throughout the world right now, and we have multiple domains that cover each geography. We need to decide on the best way to extend our directory. Will we use Active Directory in servers in virtual machines within our virtual network, or will we use Active Directory domain services? In our case, we used Active Directory in VMs in our Azure Virtual Network for a very specific reason. Some of our applications have a dependency on application partitions that are built into Active Directory. Those application partitions are not available in Azure Active Directory domain services. Also, because we have multiple domains, Azure Active Directory domain services only supports a single domain tied to our tenant. Having completed our investigations, the next step was for us to plan our migration. For our network migration, we've done our review, so we know what we're going to need, and this is a good time to make adjustments. And you all know that having to change your addressing scheme is a chore, and mostly because you have to make sure that you're not breaking anything as you're changing your networking. Just as with the zombie servers, this migration was the perfect opportunity to clean up and streamline our network. We renamed the NAT DMZ to just a DMZ subnet. The Hyper-V LAN was not going to be needed anymore because we're not going to have any virtualization hosts running on premises. And the ghosted subnets, I never understood what that name actually meant as I inherited this environment. So we're going to get rid of that subnet, and we're just going to have our DMZ and production subnets. On premises, we use 10.0.0.0.0 WAC22. For our cloud environment, we picked an address space that did not overlap with any other sites and that had the same class of addresses, which was 10.10.0.0 WAC16. From there, we're going to carve it up with a DMZ subnet and a production subnet, just like on premises. The traffic is going to be controlled across the network, and for that, we're going to use network security groups and the Azure firewall. Our end results for our target environment will be one where all traffic to and from the internet and the on-premises network are going to be controlled by the Azure firewall. We're going to have our production subnets and we're going to have our DMZ. So, that's our target network environment. In terms of storage migration, well, after we'd cleared out those old backups that weren't needed anymore, and after we'd figured out all the duplicates and removed them, we realized we had about 75 terabytes of data that needed to be moved. So that's going to take approximately 97 days for us to move across the wire using our 100 megabits per second internet connection. Not all of our offices have large pipes, and of course if we had a fatter pipe it would take less time. But in our case, that's what we have to work with, so we decided that Azure Data Box was our only real option to transfer the data in a reasonable time. This table gives a quick summary of how much time is required to transfer your data depending on your data volume and bandwidth. So if the time is too long, you need to either reduce your data, get a fatter pipe, or use an alternative approach such as DataBox. We followed the standard DataBox process. We created an order in the Azure portal, providing shipping information and the destination storage account for the data. Azure prepared and shipped the device with a shipment and tracking ID. And once the device was delivered, we turned it on and we connected to the device. We configured the device on the network and mounted shares on the host computer from where we planned to copy the data. And next, we copied our data to the DataBox file shares. We then prepared the device, turned it off, and shipped it back to the Azure Data Center. Data was automatically copied from the device to Azure, and once complete, Microsoft makes sure the device disks are securely erased. As I mentioned, for our Active Directory, we decided to use Active Directory in VMs inside our virtual networks. We used Active Directory sites to define the sites in Azure. So each subnet where we deployed the domain controllers is going to be its own Active Directory site, and therefore going to control authentication requests. We wanted to ensure that authentication requests don't go back across the WAN link or the site-to-site VPN to be processed. We have 2 domain controllers in our Azure environment as part of an availability set, and that way we make sure that we have significant availability for our domain controllers within our virtual network. Let's take a look at how to extend AD to Azure using Azure VMs. So we'll look at how to extend AD into an Azure-based domain controller running in an Azure virtual machine. Here we are, I'm on my Azure VM, which I'm going to use as a domain controller. And you can see the first step there I've executed is to install the Windows feature AD domain services and have domain services installed on the box. As a next step, I'm going to promote this to be a domain controller, and to do that we'll use install ADDS domain controller. This domain controller is also going to include an integrated DNS zone, and that's because we're going to enable server-to-server name resolution. We're able to resolve DNS names from the cloud to on-premise and from on-premise to the cloud across all of our estate, so that even in hybrid applications the different machines can find each other. We'll let that process run. That obviously takes just a little while. We've sped it up here for the purposes of the demo. Okay, and that will need to restart, and while that restarts we're going to switch over to our existing on-premises domain controller and go into the Active Directory sites and services, and we're going to use this to create a new site for our new domain controllers that are running in Azure. We'll create a new site, call it Azure VNet. And the reason we're doing this is so that authentication requests from Azure don't have to traverse our site-to-site VPN onto our on-premises domain controller. We can keep the Azure-based authentication requests focused on our Azure-based domain controllers. So we'll specify the subnet range there and link it to that particular site. Okay, that's done. And switching back to our Azure portal, you can see here for our virtual network we have the on-premises domain controller configured as the DNS server, and we're going to modify our DNS settings for the virtual network to specify our new Azure-based domain controller instead. So obviously in practice you would probably have 2 domain controllers here running either in an availability set or using availability zones for high availability, and you would also need to make sure that you refresh the DHCP on any existing VMs in that virtual network to pick up that DNS change. So a brief word about data migration. This session is going to be about migrating our VM application. Data migration is a separate topic. If you're looking to migrate to SQL Server in ISVMs or to a PaaS service such as Azure SQL Database or Azure SQL Database for MySQL, well, Microsoft has assessment tools and migration tools to help, but this session will not cover those today. For our VM migration, we used Azure Migrate. Azure Migrate is a hub bringing together application, data, and infrastructure migration tools. Azure Migrate also delivers a unified, integrated experience across Azure and third-party tools, so you can pick the tool that best meets your needs. Azure tools such as Server Assessment, Server Migration, Database Migration Service, and the App Service Migration Assistant are all now available through Azure Migrate. The same is true for ISV tools from Carbonite, Cloudamize, Corent, Device42, Turbonomic, and Unify Cloud, with additional integrations on the way. Azure Migrate supports assessment and migration of VMware, Hyper-V, and physical servers. In most cases, an agentless migration is possible, so nothing needs to be installed on your production servers themselves. Let's walk through the migration process using Azure Migrate. Okay, for this demo we're going to be looking at Azure Migrate, migrating an existing set of VMs running an on-premise application up into Azure IaaS VMs. Okay, so we need to choose what application we're going to migrate first. If you have a portfolio of applications, you want to start with some applications that are relatively low risk, not something that's going to be business critical for you. And in this case, I've chosen this application called Mercury Web. It's an internal health portal, helps people with exercise, nutrition, maybe book exercises in the gym and so on. So this health portal, it's not going to move our share price if we have this out of action for a little while, if something goes wrong. So it's a good place to start and build up some confidence, build some experience and so on. So you can see here the application is up and running in Hyper-V on my on-premises network. That's working just fine. And we can just go into the database for the application, just have a little look at how that is configured. Let's log into the database server and we can go into our databases, Mercury Health, and we can see the tables that we have here. We have our exercises table and so on. Great, so that's our on-premises starting point for our migration. Now we'll switch here to the Azure portal and we're going to create a resource and simply search for Azure Migrate. And here it is. So we're going to create an Azure Migrate project. So you can see here Azure Migrate is a hub for various migration tools. There's tools for data migration, there's tools for web apps and even integrating with Azure Data Box. But in our case, we're focusing just on server migration. We're going to use this to migrate our application across. So we click Add Tools, and then we specify a resource group for our migration project and give the project a name. Tailwind Traders Migrate. And we choose a geography, not an exact region, but just a geography this migration is happening in. And we can now choose an assessment tool just for the assessment phase, and we're going to use the Azure Migrate Assessment tool, which supports VMware and Hyper-V, but doesn't support physical machines for this demo. But the Hyper-V is where we are. So that's for our server assessment, and you can see there's also a range of third-party tools here. There's more if I scroll down, and they obviously have their own feature sets. So we'll stick with the Azure Migrate tool, click Next, and now we choose the actual migration tool. The first one was the assessment tool. This is the migration tool we'll use. And again, we'll use Azure Migrate Server Migration, which for Hyper-V is based around Azure Site Recovery under the hood. So let's add those tools. Okay, that's successful. And in here in Azure Migrate now we click the Discover button to choose the machines and discover the machines for our assessment. We select Hyper-V, and the next step is to deploy this appliance. We download the VHD file for a VM, and we run that VM within our Hyper-V environment. And that machine has been set up for us actually, just to speed the demo up. We have deployed that machine, and here it is. And if we go into the appliance application, this is just running locally within this appliance. We can just work through the wizard here. Now the appliance needs access to the Hyper-V host, but it doesn't need access to any of our actual VMs. It will get all of its data by interrogating the host here. So it'll check that we have internet connection, time sync, and that everything is up to date. Now we register with our Azure Migrate service, so we need to provide our Azure subscription details. So we'll log into our Azure subscription here. Okay, and we can now specify our appliance name. Okay, we'll register that against our Azure Migrate appliance. We've registered our Azure Migrate appliance against the Azure Migrate service. We're going to have to talk to the Hyper-V host, so that will need credentials, so we save those. And now we specify the host that we're going to talk to. Now this can be a list of servers if you have a larger Hyper-V environment, but for this demo we just have the one Hyper-V host. So we list the Hyper-V server here, and we can validate that we have connectivity, and then okay, and then validate again. And finally we can save and start discovery. And this will go through and to see what virtual machines we have running on that Hyper-V host, and they will, after a few minutes, they will surface here in the Azure Migrate assessment environment. And we would like to check the dependencies here. Maybe there's other services that are taking advantage of our database, and if we migrate the database, we'll break them. And we can use that using the dependency view within the Azure Migrate service. However, the first thing we have to do in order to use that dependency view, we have to create an OMS workspace, but we first need to set up a Azure Migrate assessment as well. We'll do a conventional assessment before we start looking at the dependency view. For the dependency view, we also have to install these agents on the on-premises VMs. You can see that the details of the agents are there, and we also have to configure with the workspace ID of the Log Analytics workspace. Okay, so while those agents are running, they've been installed for us to just accelerate the demo. We have the dependency view here, but before going into the dependency view, we're going to create an assessment. We just click Assess here within the migration tool, and we give the assessment a name, and we can then look at the assessment settings. The View All link is important here. This lets us choose how the assessment is going to be computed. For example, the pricing will vary per region, so we may need to check that we've chosen the correct Azure region, and we'll choose what kind of storage we're going to use, and we can choose whether reserved instances will be used. Of course, that can have a big impact on the pricing. And we can look at how the sizing will be computed. Is it based on the size of the existing infrastructure, or is it based also on the performance that those machines are under? If they're lightly used, we can probably get away with smaller machines. And we can look at the time window that performance data has been gathered over, specify what VM series we're going to accept. If we're using performance-based, we can give a comfort factor, 1.5 in this case, to give a bit of headroom on the size of the machines. Specify uptime, for example, that all affects the pricing. And also whether hybrid benefit is being used. In many cases, you will be able to use hybrid benefit, of course, in a migration scenario. Okay, so that's great. We'll specify a group of VMs that we're going to include in this assessment. It may be that you have a large environment and you only want to migrate some of the VMs at a particular time for a particular application. So let's see which ones are relevant. It's these three. We're not migrating the Azure Migrate appliance itself, so obviously we'll exclude that one. And we can then validate those settings. Okay, great. So that will create our assessment based on the data that the appliance has gathered. And if we have a look at that assessment, and we can have a look at the dependencies now for that group of machines. You can see here there's the 3 machines, and you can see the outbound dependencies from those machines. And if there were inbound requests coming into that SQL server from elsewhere, they would show on this view. And there isn't, so we're in good shape here. That means that we're safe to migrate our database. We don't have to worry about breaking something that we weren't aware of. So that's how the dependency view is very powerful. You can also drill into those tiles and see more details, such as which processes are running on each of those servers and so on. If we go into the assessment details, let's have a look at the assessment. We can see here an overview. We can see there's 3 machines. They're ready for Azure, though they do have some conditions. There's some warnings there we may want to review. And you can see a cost estimate of what this will cost to run in Azure, both for compute and storage. And you can see that's based on the size of machine that's been specified here. And of course, we can see there what's driving the costs. We can think about whether we want to reduce the size of any of those machines. Okay, fantastic. So that's our server assessment. The next stage, of course, is to look at an actual server migration. Okay, so for the server migration, we click Discover Machines, and again we specify Hyper-V, and it's very important to get the region correct here, because this is going to create a recovery services vault. The migration for Hyper-V uses Azure Site Recovery under the hood, and that vault has to be created in the correct region. So you can't change that region later. Very important to get that region right up front. So the next stage is that we need to install the Hyper-V replication provider onto the Hyper-V host. So we download the Hyper-V provider and from the Azure portal. I've downloaded it for me here, and also a key file that contains various settings. So we just add that file to the provider. As we run the provider, it will ask for the file. We just specify the file name. It has a few details for us, and then we click Next, and that will identify the various machines that are running on this particular host, and make sure that the machine details are uploaded to the Recovery Services Vault for Azure Site Recovery. So that's happened, that's done. In the Azure portal, the Finalize Registration button doesn't light up automatically. You have to kind of exit out of this stage of the wizard and go back in again. We're just doing that here, and now again we specify that it's Hyper-V, and here you can see the finalized registration lights up. You know, you have to go through that little loop to make that button enable, and we can next we can configure the virtual machines we want to replicate. Okay, so we can see the various machines that have been discovered here. There's the same 4 machines we saw before, and we're going to configure the replication for those machines. So we say yes, this is a Hyper-V, and choose our virtual machines. We can base this around the migration settings that came from the assessment phase, so we can just choose the same group of machines that we identified before from our assessment. Okay, that's those 3. Fantastic, yes, we'll have all 3, thank you very much. And next we have to look at the target settings here, so we say which resource group the VMs are going to be deployed into, and additional details such as a storage account and the virtual network, which need to be created in advance. Just as with Azure Site Recovery, the service is going to create the VMs for us and the disks, but the rest of the environment needs to be pre-configured. So you need to set up your target environment, and I've done that here already, so the virtual network is there and the subnet. And we can choose if we want to use hybrid benefit, and then we can tweak the settings here. We adjust the VM size if we want to. Maybe we've decided to make some overrides there, and we can specify which OS that each of these machines is using. And we have the option to set which disk is the OS disk, configure availability sets if need be, if we want to group our machines for high availability. And here we can see the disks for each machine. Again, if there's certain disks we don't want to replicate, we can do that. Okay, so let's replicate. And that can take a little while depending on your bandwidth, of course, and the number of machines and the size of the disks that we're replicating. Okay, so we may have to wait a little while for that to run. Of course, I've accelerated that for us, and we're going to wait until that shows as, okay, you can see here protected and healthy, so the replication is looking good there. And we can now perform a test migration. As well as the real migration, a good step is to do a test migration, just like with Azure Site Recovery doing a test failover. It's using the same mechanism. So for the test migration, we're going to have a look just to see the particular machine. We'll click for the test migration and specify the virtual network that the test migration should land in. That may be different from your final network. We can have a different migration target for that, and let that test migration start, and then repeat this for each of the machines that we want to do the test migration for. So we just rinse and repeat. Okay, so we just refresh here, and the test migration is in progress for our 3 machines. Okay, we can see that's finished. Obviously that's been accelerated, and you can see cleanup pending, because obviously at the end of the test migration, once we've validated that the machines have been created successfully, we need to clean them up again, and that's again managed by the service. And you can see here we can go in and see the machines have been migrated. If we just look at virtual machines, the ones with test on the end are the ones coming from the test migration. And we can dig into these machines, check that everything's running, check the database is configured correctly, do whatever validations we want to do at this stage. Okay. So to clean these up, we can just go back to our Azure Migrate service, and we can do the cleanup of the test migration from within the Azure Migrate server migration. So we can just click into this, look at our machines. You can see cleanup test failover is pending, and go into the machine, and you can clean up the test migration for each machine here. Okay, you can provide any notes, perhaps if there were some issues with the migration. Okay, testing is complete, delete the test virtual machine. Great. Okay, and we repeat that for each of the machines. Go in and clean up the test migration. Excellent. So now we can do the real migration. Follows a similar process. We choose which machines we want to migrate, and we can choose whether to shut down the on-premises machines as part of the migration. This can help keep things in sync if we want to. It's an optional feature we have. So let's click the migration. Okay, so that will start the migration to the network that we specified earlier, the target network environment that we've configured. And we can see here that yes, there's 3 migrated machines. And we can see if we go into our resource group that the machines are here. Obviously they don't have test in their name this time. And if we just go into one of these machines, we can have a little look to check that things are as we would expect. We'll go have a look at the database. And here I'm in my SQL Management Studio. I'm just going to connect to that new database server. I don't need to actually RDP to the database. I'm just going to connect to the database on its IP. That's 10.10.2.7. So I will just put in the password here. So talk to the database. Okay, so here's the database on our newly migrated VM. And you can see if I compare to the old database, I have the same structure here. And I can go into the tables, and you can see everything is as it was previously. The migration appears to have been successful. Next comes the post-migration steps. There are a lot of tasks to do in the post-migration phase. First, we made sure the Azure VM agent was installed on our migrated servers, so the servers could benefit from the full Azure management experience. We had to implement our governance strategy, and that meant deciding who got access to each machine, who can turn them on and who can turn them off, and who can administer them in the Azure portal, which is completely different than administrative rights within the virtual machine itself. That meant deciding who's got access to each machine, who can turn them on and who can turn them off, and who can administer them within the Azure portal, which is completely different than administrative rights within the Azure virtual machine itself. We actually had to plan our governance in advance to choose the right Azure subscription structure and the resource naming convention. We needed to make sure that those machines are monitored, and in some cases we made new instances of a machine to promote high availability. We also had to configure backup or use Azure Site Recovery to implement a full DR solution. And we made sure that each machine was integrated with Azure Update Management. Finally, let's discuss the optimize phase in our Azure migration journey. Like any business, Tailwind traders are interested in cost savings and not paying more than we need to. We tried to optimize our VM sizes during deployment, but we found that this was something we needed to revisit from time to time to ensure that each workload was still running on the most cost-effective VM family and size. We also took advantage of pricing discounts such as Azure Hybrid benefit, so we weren't paying twice for licenses we already had, and reserved instances for infrastructure servers such as our domain controller VMs, which we were confident would be running for a long time. We used Azure Cost Management to track and report our costs, making sure the business had visibility into what each application was costing them. We also review the cost-saving recommendations from Azure Advisor. That brings us to the end of our Tailwind Traders journey. Microsoft provides extensive documentation on each Azure service, on migration, and on cloud adoption. In particular, the Microsoft Cloud Adoption Framework for Azure is a set of proven documentation, implementation guidance, best practices, and tools that aid in aligning the cloud strategy for businesses, people, and technology. It helps you enable the desired business outcomes and accelerate your cloud journey. For more information, please see the link on the slide. That brings us to the end of this session. Thank you for listening. It also brings us to